All right, we are going to solve some systems of equations using elimination and or substitution. This is 5.9, number 9 and 11. And we're just going to focus on solving using substitution or elimination. So looking at number 9, and let's look at number 9. So the first thing I notice is I don't really like the decimals. I don't. So the very first thing that I'm going to do is I'm going to multiply both sets of numbers so that I get rid of my decimals. And the way I do that is if I multiply every single piece by 10, now I have bigger numbers, but I don't have decimals. Okay, so some people are fine with their decimals. I tend to get rid of my decimals as soon as possible. So I'm going to go 20x plus 5y equals to 30. Every single piece gets multiplied. Okay. Then I get 10x plus 20y equals to 85. And your guys are like, oh my gosh, Miss Johnson, those numbers are so big. I'd rather have big numbers than decimals. That's just me. So the next thing that I'm looking at is if I use substitution, which variable would I solve for? If I use substitution, which variable would I solve for? And then which equation would I solve for? So there's going to be one that's better than the others. So I wouldn't do like this x. I wouldn't do that x. Miss Johnson, why? Why wouldn't you do that x? Because like, do you see how like in the future, I'm going to subtract 5y and then I'm going to divide by 20. I do not want to think about what 30 divided by 20 is when I just got rid of all my decimals, right? So I'm not going to use that x. So then you go up to this x and you're like, ooh, but Miss Johnson, the 20 divided by 10, that's pretty good, right? Yeah, but that 85 divided by 10 is now just bringing me back to decimal land. So no, I'm not going to do that. Let's try this y. Can you think about this y really quick? What do you think? Solving good or solve? No, I don't want to solve for this. Is this a good one to solve? Yeah, this one's a good one. Okay, so the very first thing I'm going to do is I'm going to solve this one for y. So I'm going to go 20x plus 5y equals to 30. So the first thing I'm going to do is I'm trying to isolate that y, so I'm going to subtract 20x. So then I get 5y equals to negative 20x plus 30. Hey, Miss Johnson, can I add those together? No. Hey, Miss Johnson, why can't I add those together? Because x cannot be added to a constant. That's like saying $21 bills plus one $20 bill is 21. And you're like, 21 what? It's not 21 of anything. I mean, it's 21 bills, but that's not how much money you have, right? Okay. So then I would divide by 5. So let's go divide by 5. And I do it to every single piece because that keeps it clean. So I get y equals to negative 4x plus 6. And I'm like, yay. Right? And y is by itself. So whenever y is by itself, then I say, hey, is there any way that on my sandwich you could put avocado instead of bacon? So I go up to my other equation and I look for bacon and I'm going to put avocado right there instead. I'm going to say it again. Hey, on my sandwich, is there any way you could put avocado instead of bacon? And they're like, sure. So on my sandwich, meaning the other equation, instead of that y right there, I'm going to put avocado. So I'm going to copy that equation, except for I'm going to leave a big placeholder for my avocado because I'm hoping they're going to give me a lot of avocado. That's legit. I really do like avocado. And then I'm going to take my y stuff, my avocado, and I'm putting it right there. Okay. So that's why I needed a big placeholder for my avocado. And then now I just transported you back into 8th grade and you know how to solve this equation. Okay. So all the stuff that I just showed you, that's the 9th grade stuff, right? Solving and then substituting. From here on out, this is you back in 8th grade. And if you're like, I don't remember how to do this, no problem. But I'm just telling you this, I'm leaning on the fact of your skills. So here, the very first thing that I want to do is I want to distribute. So I'm going to keep that 10x exactly like 10x. But now I'm going to distribute. So that becomes 20 times negative 4 is negative 80x. And 20 times 6 is 120. And you still are like, hey, Ms. Johnson, those numbers are so big. It's okay. Just deal with them or use Desmos. It's not that. Don't be like, big numbers. The rules change. No, they don't. It's exactly the same. Whether I'm kind of counting like $1 bills or $10 bills or $20 bills or $100 bills, it's counting is still the same. All right, now I'm going to simplify. So these two together, 10 of them minus 80 of them is negative 70 x's. And then the rest of this stays exactly the same. I color code everything so that you see what I changed versus what I kept the same. So if you forgot what we're doing because you got like mixed up in the mess, we're trying to find out what x is. So I'm trying to isolate x. I'm pushing everybody away from x. So that means I'm going to subtract 120. And then this is where you're like, Miss Johnson, those big numbers. So use a calculator. It's okay to use a calculator. I'm not going to use a calculator. So 120 minus 80 is 40. And then 5. So the negative 35 is what I got. I think that's right. Could be wrong. But I'm pretty convinced that that's right.
That's right.
Thank you. Okay, so then I'm going to divide by negative 70, and you guys are like, no, Miss Johnson, the fractions. So yes, as a mathematician, I like fractions more than I like decimals. So 35 over 70, I recognize as half. A negative divided by negative is a positive. So x is equal to 1/2. So I'm going to put this in a box. I'm going to put an answer little guy over here and put x in the x spot. Now, I'd be done if I was in 8th grade, but now I'm pulling you back into 9th grade. What do I still have to find? Still have to find my y.
The y.
Yes, very good. So I'm going to just substitute back in. What does that mean, Miss Johnson? It means I'm going to take my y stuff and put it into my x stuff. Okay, so I'm going to copy that exact equation, y equals negative 4 parentheses. I'm just going to leave a placeholder there. And I'm putting that guy right in there. 1/2. Right? So the y stays the same, equals, and then plus 6 stays the same. Negative 4 times half is negative 2. So that's negative 2. Negative 2 plus 6 is 4. So my answer, I think, is 1/2 comma 4. I think it's 1/2 comma 4. So 2 ways that I would check my answer is, number 1, I take my answer and I go back to my original equations, the one that they gave me, not the ones that I made. All of these ones here are the ones that I made. Here, I'm going to plug it into this equation because that's what they gave me. Okay, so here goes. I am going to plug in. I'm going to use my head just because I can. So 2 times half is 1. I'm going to write my answers up here. So I got 1 plus, what's half of 4? That's 2. So that's 3. Yay. So far, so good. And then I got half plus 8, right? Because 2 times 4 is 8. Is 8.5. Yay. Miss Johnson, she's very happy. Do you know why she's very happy? Because she got the right answer. That's one way to check it. You could also check it using your, let's see, Desmos. So I'm going to turn these guys off. Actually, I'm going to delete them. So I got, let's see, 2x plus 0.5y equals to 3. There's one equation. And then I got x plus 2y equals to 8.5. And I'm like, where's my solution? Well, my solution is half comma 4. Oh, there it is. It's right there. And it's half comma 4. And I'm clapping for myself because I did a good job. Yay, Miss Johnson. So on a test, this is really fabulous. This is why I call this the redemption chapter. You could check all your answers and make sure and ensure that you are going to get the best possible grade on your test. Okay. Number 11. So I'm going to just draw a little line here so everybody knows that this is going to be number 11. So I am going to use a different method on this one because I just used substitution. So now I want to use elimination. Elimination, if you remember, let's look at a previous example, like number 7, right? Those 2x and 2x eliminated because they are the same. I don't have any samesies when I look at 11. So I'm going to have to do some multiplying to get to the samesies so I can eliminate. Okay, so I'm going to start by just copying this. And some of you are like, ooh, Miss Johnson, that fraction. Okay, we can get rid of that fraction by multiplying by the denominator. So I'm going to copy the top equation. So 3x plus 5y equals to -3. And you'll like multiplying because you'll see what happens in a second. So I'm going to multiply each of these guys by 3, okay, to every single piece. Think about like huge distribution. So I get 3x, I get 6y, and I get, well, okay, let's do this here. If I multiply -4/3 times 3, does everybody kind of see how they cancel? That was the whole point. Okay, so that's equal to -4. And look what I have here. Look at that. I don't have any more fractions. So now I'm a little bit happier. So, and I even have samesies. So I'm going to subtract. I'm going to go big on top. I do a big subtraction sign and I keep saying I'm subtracting. So these two, 3x minus 3x is 0. 5y minus 6y, that's -y, equals to -3 minus -4 is 1. And I'm going to check my subtraction because Miss Johnson, she makes mistakes. I'm going to take a second to think about, did I do that right? I'm just going to look over it. So this is the equivalent of, in construction, they say measure twice, cut once. There's a phrase in the outside. They say something like an ounce of precaution is worth a pound of cure. It means if you take the time right now to check your work, you won't have to go back and fix all your mistakes because you checked your work. All right. If -y equals 1, that implies that y equals -1. That makes sense. If the opposite of a number is 1, that means the number must be -1. Okay. So some people think, okay, well, what do I do from here, Miss Johnson? Well, since they gave you x and y in the equations, that means I have to find both x and y. So I'm going to choose an equation from my original set and then plug in. I'm going to use that first equation. So I'm going to copy exactly what I see, 3x plus 5, and then I'm going to leave some space for y. And I'm going to take my y and I'm plugging it into there. And then now I just transported you back to 8th grade, so I'm going to continue. So I got 3x, and then I got -5 equals to -3. So I'm going to add 5 to both sides. So I got 2 equals to 3x, which means that x equals to 2/3. So my point is 2/3, -1. Which I'm like, ooh, that's kind of funky looking. I'm still going to use algebra to check my answers. 2/3 times 3 is 2 plus -5 minus 5 is -3. This is good. I got 2/3 minus 2. They're saying is -4/3. So -2 is -6/3. Yeah, this is right. So the other way that you would check it is just using your graphs. Okay. Very good. So if you look at these, and you look at elimination, let's take a second. Look at elimination. What's the part that's confusing? Sorry, this is substitution. Look at substitution. What's the part that's confusing? Okay. Figure out whatever part is confusing you and walk very carefully around that part. If it's solving for y, then just remember all you're doing is you're taking your solving equation skills and you're solving for equations that have more than one variable. Okay, substitution is not a big deal. Simplifying is not a big deal. I think it's going to be this very first section in here. This part in here is where students may make a mistake, because the rest of it, like once you know what y is, when you plug it in, that's straightforward. Simplifying, straightforward.
Miss Johnson?
Mm-hmm.
The part I'm having trouble understanding is how you turn the x on number 11 into 3.
This one?
The bottom one.
Yeah. So here, I didn't like the fact that I had a fraction. So one of the ways that you can deal with that in equations is just by multiplying every single piece by your denominator. This works if you're multiplying equations. It doesn't work if you just had a -4/3 just kicking it right here. Right? If I had a -4/3, I can't just be like, I don't like you, I'm going to multiply by 3. Because then if that's the case, then I can do that in my bank account. Right? Like, ooh, I don't like this much money, I want more. Let's multiply by 1,000,000. It doesn't work like that. So because you can't just multiply numbers like that, but you can do it to an equation, because if you multiply both sides, you're still the equation is staying equivalent. They may not look the same. Think about a $20 bill and 10 ones and 2 10s. They don't look the same, but they're equivalent, right? So same thing goes for here. When I was using elimination, what part didn't you like? Now, some systems are going to be easier to do one way than the other. And that just takes skill in order for you to figure out. It's almost like you're looking into the future of you solving this problem and saying like, "Ooh, I don't want to divide by 20 because that's going to give me some crazy fraction. Yuck." Right? So I usually look into the future to figure out which one is easier. Like pretend that you're at a fork in the road and you're looking down this way and you're like, "Ooh, I don't like that way." And you look down this way and you're like, that's not so bad." But what if you don't like both ways, Miss Johnson? You're just going to choose the one that looks less, horrible. Okay. Very good. Thank you for listening.